This is what we did yesterday. Some of you struggled with items like this one because it doesn't look like a polygon that you're used to, like this. Okay, it's a little different. But first I want to start out with the basics, and I want you to have these written down in your notes. So you should all have your notebooks out. Oh, wait. All right, thank you for those of you that followed instructions and have your notebook out and are going to write down these notes. Here are some of the things that we need to know, and this has to be in your notebook, not on the assignment. Okay, number one, first thing that you need to know is the sum of all angles in a triangle. And I know you guys wrote this yesterday, but I'm going to have you write it down again because it takes 28 times to create a habit. They equal 180. 180 degrees. That's the first thing you need to know. You need to know the formula for finding the sum of the angles, all angles in a polygon So we're talking about the sum of all angles in a polygon is going to be the number of sides minus 2 times 180. Here's the third thing you need to know. I'll give you time to write that down. Whoops. All right. So super important. These are 4 things that you really need to know in order to do well on this test. And these are things that aren't only going to need to know now. You're going to use this throughout the rest of your mathematical career in high school. And beyond if you choose to do so. Okay. So to sum up, sum of all angles in a triangle always equal 180 degrees. Now the thing to note is that a triangle has 3 sides. So if you're talking about a figure that does not have 3 sides, it is not a triangle. Okay? Make sure you make that distinction. Secondly, the formula for finding the sum of all angles in a polygon, that means it has more than 3 sides, is simple. You count the number of sides, you subtract 2, and then you multiply by 180. Sometimes you're going to be asked to find the individual measure of the angles within a polygon. We start with the same formula, but then we divide by the number of sides. So whenever you see this formula, the n is equal to the number of sides of a polygon. So if my polygon has 8 sides, this is going to be 8 minus 2 times 180 over 8. If it has 4 sides, it's 4 minus 2 times 180 over 4. So these numbers are going to be the same. And then lastly, when we talk about supplementary and complementary angles, you need to know this in order to be able to find exterior angle measures. So angle A plus angle B in a straight line equal 180. When you have a straight line, we call those supplementary angles. Could it be more than 2 angles? Could I have this divided into 3? Question. Answer. Could I divide this straight line into more than 2 angles? Yes, I can. Then the rule would still apply. A plus B plus C would equal 180. The sum of all the angles in this straight line are always going to equal 180. No more, no less. If you got more or less, something's wrong. Check your math. When we have a right angle signified by that box and it's divided, the sum of those angles will always equal 90 degrees. It doesn't mean it's going to be 45 and 45 because we don't know what the split is. Sometimes we will, sometimes we won't. But they will always equal 90 degrees. Okay, super important when you're doing this. All right, so yesterday you had some homework that looked a lot like this. So here it says use triangles to find the sum of the interior angle measures of the polygon. So what we need to do here is create triangles, right? So if I join these lines here, I have a triangle, right? If I join these lines here, I have a triangle, right? And if I join these lines here, I have a triangle. Correct? So how many triangles do I have? So if I want to know the angle sum of the interior angles, could I do that? Yeah, right? I have my number of sides. Could I just use my formula, number of sides times 180? Right? I don't care how you find the answer. What matters is that you do. So if I have 1, 2, 3, 4, that's going to give me 4 times 180, right? Because every triangle angle sum is 180. So 4 times 180 is what? How come you guys don't have calculators? I ask you this every day. I don't care. I get 4 times 180 equals 720. But let's check it using our equation, okay? How many sides do I have? 1, 2, 3, 4, 5, 6. So if I follow my formula, 6 minus 2 times 180, what's 6 minus 2? Oops. 4 times 180 is what? 720. 2 ways to fry that fish, right? Both ways worked. Both ways worked. First, I divided into triangles. I counted my triangles. I multiplied that by 180. I got 720. The second way was using my formula. Number of sides minus 2 times 180 ended up being 4 times 180 or 720. Either way works. Is that like an aha moment for you guys? Yeah. Okay, so 2 ways to do this. I don't care. It does not matter to me how you get to that answer. What matters to me is that you can show me that you understand how you got there. All right? Anybody have an answer?
Yes.
Nathan, what do you get? 5 what? But what's my sum of interior angles? Karina, what did you get? You didn't get that far. What far? How far did you get? I can't hear you. That's what I want to know. What'd you get? Huh? What do you mean you didn't get the answer yet? I'm going to take this top vertices here and I'm going to divide into triangles. How many triangles did I get? 3 triangles. I don't know how you guys are getting more than 3. You're just going corner to corner. I can't go to here because it's not going to create a new triangle. I mean, I can draw a line there, but I'm not going to get a triangle out of it. So if I end up with 3 triangles, I'm going to do 3 times 180, which is going to equal 540.
I was right. I did that in my head.
Did you do it on the paper, though?
Yeah.
Then why didn't you tell me you had an answer?
I did. That's how okay.
Again, so let's think of the other way to do it. Let me count my sides. This is side 1, 2, 3, 4, 5. So I'm going to use the formula over here. 5 minus 2, right? 5 sides minus 2 times 180. 5 minus 2 is 3 times 180, which is exactly what I had here, which is 540. Either way, 2 ways to do it. I don't care how you did it. Give me that you have the answer 540. All right, we're going to move on. Here's the sum of the interior angle. So I want to know exactly here, and it doesn't matter, I don't care what method you use. Same thing for 3 and 4. We're going to move on, though. Okay, number 5. Number 5 is written in words. It says, can an octagon have interior angles that measure this? Okay, so an octagon has how many sides? Octagon. 8, like an octopus has 8 arms. So I have 100, 156, 125, 90, 175, 130, and 140. Well, I'm going to go ahead and say I have 8 minus 2 times 180. What does that give me? So 6 times 180 equals what? 1080. Okay, so I'm going to go ahead and I'm going to take my calculator and I am going to add up those sides. Yeah, you can always use calculators. I tell you guys to bring a calculator. I don't know why y'all don't own calculators. Decent calculators for you to bring in here. I've said that since day 1. So all I'm doing is taking all of my angles that they talked about here. Poopy. Let's try it again. 100, 156, 125, 90, 175, 134, 160, and 140. So I took all of these angles and I added them together. What did they total?
1,080.
And what did I say that some of my interior angles would measure?
1,080.
So can an octagon have interior angles that measure those measurements?
Yes.
Why? Because the sum of the interior angles of an octagon are 1,080. Okay? You understand? I don't know. So here we have the measure of interior angles. This is exactly what you guys did yesterday. I'm just reiterating what you guys truly struggled on. I think you did better on 3.4, not so hot on 3.3. Okay, so a stop sign is the shape of a regular octagon. What is the measure of each interior angle? Okay, stop sign is an octagon. What do we say? How many sides does an octagon have? 8. So they want to know the measure of each. That word is key. Each interior angle. That means I want to know this. I need to do this. So we said that an octagon has how many sides? 8 sides. We just finished doing that up here, right? 8 minus 2 times 180 equals 1080. So I can just take that information that I already have and divide it by 8. Right? Because that's the number of sides of an octagon. So that gives me 135 degrees. So to answer the question, I take what I already know. Can you borrow from what you know already? If you've already solved a problem with an 8-sided figure, do you have to do that work over again? No. Or can you just transfer that information? Just transfer that information. Right? Thank you. Okay. These two are just using this formula. I'm going to have you guys do those on your own. We went over it yesterday. But let's look at number 9 and 10. And these will be on your test tomorrow or some similar. And I want you to really, really understand that. Okay, so here I have a figure and it wants me to find the exterior measure, x. I don't have any numbers. How am I supposed to do that? What can I do to find the outside measure here? Matthew? Count the sides. That's something that's going to be very important. So 1, 2, 3, 4, 5, 6. So I have 6 sides, right? That's a good start. Is there something that I could do with that information to find my answer? So So you want me to use this formula here, right? Because that's going to give me the individual angle measures inside, correct? Okay, so let's go ahead and do that formula. So 6 minus 2 times 180 over 6. This gives me 4 times 180 over 6. What's 4 times 180? 720. And then divided by 6, I get 120. So if I know that each of these inside angles are 120, can I figure out what x is? How? What can I use? Pointing to it. Supplementary angles, right? If this one's 120, how can I figure out what this one is? Would I know that they add up to? What do they add up to? What does this angle and this angle add up to? 180, right? So can I subtract 120 from 180 to find my x? Right? What is the subtraction then? 0 minus 0, 8 minus 2 is 6, and that's 0. So x is equal to 60 degrees. Using that supplementary angle concept. So here I have a little bit of different information, right? Here it's set up a little bit differently, but the same thing applies. This is going to require a little bit more work. Okay, so I can tell you that from here to here, what's my measure going to be? 110, right? Because 110 plus 70 is 180, correct? Here I can tell you that 180 minus 82 is going to be 98. So now I have this measure and this measure, right? Here I have 36 and 180. So, or 180 minus 36. This angle measure is going to be 144, right? Here's the kicker. This is x and this is also x. So these two here are going to measure the same. But I don't know what that is, do I? Do I know what they measure? Can I figure it out? No. But what I can do is something else. Let's count my sides. I have 1, 2, 3, 4, 5. 5 sides, right? So if I did 5 minus 2, I'd have 3 times 180, right? So I want to know the total measure of the inside. What's 3 times 180? Don't all answer at once. You're overwhelming me.
540.
Thank you. Okay, so I know that these guys here, the inside, are going to equal 540. I'm going to call this y and this y. They're the same measure. I know this because their supplementary angles are both x, which means it's the same. So if I add these two up, I'm going to equal 180. I got to find y first. So I'm going to say 2y, because that's y and y, plus 98 plus 144 plus 110. They're all going to equal 180. So I'm going to add these guys up. 98 plus 144 plus 110 is going to be 2y plus 352. Oh, sorry. It should equal 540. Equals 540. So far, so good. Two-step equation. Subtract 352 from both sides. It's going to give me 2y is equal to 188. Divide it by 2. Y is going to equal 94. So this is 94, and this is 94. Can I find x now?
Yeah.
How do I find x? How do I find x now? Angel? Supplementary angles, right? So if I take 180 and I subtract 94, what do I get? What do I get? 180 minus 94. What do I get? Thank you. 86. Can you guys do this without a calculator?
Yeah.
It appears not.